This is chapter 2, kinematics of physics. First question, I call it the OG path. A particle at time t has path x as follows: x of t equals a cos pt and y of t equals b sin pt, where a, b and p are positive constants and b is greater than a. So there are four options given. This is a multiple choice question in which one or more than one can be the correct answer. So A is path of particle is ellipse, B velocity and acceleration are normal to each other at t equals pi by 2p. C is acceleration of particle is always directed to a focus. D is distance traveled in t equals 0 to t equals pi by 2p is A. Now we have to check which one is the correct option. So let's start. So from here we can write that um, cos pt equals x by a and sin pt equals y by b, and you square it and you add it to each other, then it'll be cos square pt plus sin square pt, which is 1, equals to x square by a square plus y square by b square. So this is clearly an elliptical path, okay, with the equation, and so we're just going to draw it. Let this be an ellipse. It's not a perfect ellipse, but it works. So y x, okay, so this is the elliptical path, which is x square by a square plus y square by b square equals to 1, and this point is a comma 0 and this point is 0 comma b, right? And a point on this is determines the path. So this r vector determines our path. So this r vector keeps on going like this. Okay, now so the first option is correct. Path is ellipse. Now we move on to the second part, which is velocity and acceleration of particle are normal to each other at t equals pi by tp. Now x and y displacement is given, right? So we can find out the velocity in x direction. So that will be dx by dt, which is vx, equals to minus ap sine of pt, and similarly d square x by dt square, which is ax, will be minus ap square cos of pt. Now dy by dt, which is vy, equals to bp cos pt, easy differentiation, no big deal, and acceleration in y direction is d square y by dt square, which is ay equals, इसका माइनस हो जाता है sin of pt. Okay, now we have the velocity and acceleration. Now what are these? Now we have to find out what their value is when t equals pi by 2p, right? So at t equals pi by 2p, the value of this will be, okay, pi by 2p, right? Okay, so this implies that pt equals pi by 2, right? Because pt is like the theta in all these equations, so we'll just take this. Now pt equals pi by 2, so that means all the cos values will be 0, right? So therefore ax and vy equals 0, and we get vx as minus ap and ay as minus bp square, and so there is only component of velocity in x direction and component of acceleration in y direction, right? So that means uh, net velocity will be in x direction and net negative x direction, and net acceleration will be in negative y direction. That means that the velocity and acceleration are normal to each other at t equals pi by 2p. So this is also a correct option. Right. Now, just a second. Right. Okay. Now let's do one thing. Right. Okay. Yeah. Okay. Yeah. So now the third option is acceleration of particle is always directed towards a focus. Okay. So for this question, first, what we do is we find out the uh, net acceleration. Right. So net acceleration from previous things we get as minus ap square cos pt as the x and minus bp square sine pt as the y. Okay, so this means now we can take a p square minus p square common here, right? Minus p square, and we get a cos pt, which is basically our x, right? So there'll be xi plus yj, right? Now xi plus yj is basically r vector, the displacement vector, right? So in the ellipse we had, this was the r vector, correct? This is the r vector, and in the same, so now we're given that acceleration is minus p square r vector, which is in the minus direction of r vector, right? So it'll be like this. So this is the direction of a. This is the direction of a towards the origin, towards the origin, and that satisfies our third option, which is acceleration of particle is always directed to a focus. So this is also correct. Now the fourth one is distance traveled in t equals 0 to t equals pi by 2p is a. Now let's try this out. Distance traveled. Okay, so this means that okay, so we know that at t equals 0, the particle r vector is a comma 0, and at t equal pi by 2p it is at 0 comma b. Okay, so a comma 0 and 0 comma b, which basically means that at one point it is here, this is t0, and at t equals pi by 2p it's here, so it moves like this, right? So basically the displacement from t equals 0 to pi by 2p is equal to half into elliptical curve, right? 1 by 4th of elliptical curve, which is definitely not a. Okay, yeah. Okay, let's move on to the second question. Okay, yeah. So our second question is, I call it the stupid boy. A cart is moving with constant acceleration a. A boy in the cart throws a ball forward with velocity 10 meter per second at an angle of 60 degree with the horizontal. The boy moves forward by 1.15 meters on the cart to catch the ball from the height he threw it at. So what's the constant acceleration a? We have to find out. Okay, now in this question, first we'll draw the cart, right? The cart is like this. Now let's say the boy throws it from this point on the cart. Okay, so it goes like this with a velocity u, 60 degrees, right? And let's say he moves forward till here and catches it at the same height, right? So it goes like this. This is the path, right? Where this is 1.15 meters, okay? And the boy is here now. So, and the velocity of the cart, let it be v, right? So, now first we'll take two perspectives. One is from the perspective of an observer uh, on the cart, and one is from the perspective of ground, right? From perspective on cart. Okay, now on cart, the particle velocity in y direction is basically uy is u of sine 60, which is 5 root 3 meter per second. Okay, the displacement in y direction is obviously 0 because it comes back to the same height. Acceleration in y is minus 10 meter per second square, which is basically gravitational pull. So therefore, with equation of motion, Sy equals uyt plus half ay t square, right? So this we get as, so this makes t as root 3 second. So it basically takes the particle to go from here to the hand of the boy to where he catches it in root 3 seconds. Now we'll take the other perspective, from perspective of ground, right? Now in perspective of ground, we know that the displacement of the ball, of the particle in the x direction, right? So Sx of ball is basically equal to the time taken into this velocity in the x direction, right? Now velocity in x direction from the perspective of ground is basically v, which is velocity of cart, plus u cos 60, right, into the time taken to for the boy to catch the ball, right? So Sx of ball will be v plus 5 into root 3. Now Sx of boy, right, in total equals to 1.15, which he moves on the cart, plus the amount uh, distance the cart covered in time t, which will basically be vt plus half at square. Vt velocity of cart and a is the acceleration of the cart, right? So this becomes 1.15 plus v root 3 plus 3 by 2 a. Okay, this is the Sx of boy. Now since the boy catches the ball, the displacement of boy will be equal to the displacement of ball, right? So the boy goes forward by 1.5, the cart also takes him forward by some distance, and the ball goes from this point, from where the boy threw it at, to the point where he catches at, right? So they will both be equal, and with the help of this, so v plus 5 into root 3 equals 1.15 plus v root 3 plus 3 by 2a. V root 3 gets cancelled, and a becomes approximately 5 meter per second square. Okay, now this is the second question. Now let's move on to the third question, which I call the stoned graphs. Okay, so particle moving along straight line has a velocity displacement graph as this. Okay, now it goes from a velocity v naught to 0 in displacement x naught. Now what does the acceleration displacement graph look like? That's the question. Okay, now what is the approximate equation of this graph? So this will be v equals, the slope will be minus v naught by x naught into x plus v naught. This will be the equation of this graph, right? So okay, let's take this equation here and write v equals minus v naught by x naught into x plus v naught, right? Now let's take derivative of this with respect to x. Dv by dx equals minus v naught by x naught, and if we multiply it by v, now we know that v dv by dx is basically acceleration, because v dv by dx, what is v? Dx by dt into dv by dx. Dx cancel, which is acceleration. Okay, so acceleration equals to minus v naught by x naught into v, right? And v from this is minus v naught x naught into x plus v naught, and so this simplifies to be plus v naught square x by x naught square minus v naught square by x naught. Okay, and this is an equation in x where v naught square by x naught square is basically slope, and minus v naught square by x naught is the y-intercept. So the y-intercept is negative, right? And since it is negative, it will be okay. So let's remember that the y-intercept is negative and the slope is positive. So it's definitely not this graph. It's definitely not this graph. Okay, and since there is a slope, it is not this graph. So it has to be A. Okay, now that is done. Now let's move on to the fourth question. Okay, now the fourth question is basically, okay, I call it the bloody streams. There's an A part and there's a B part. So we're told that the boat speed in still water is 5 kilometers per hour. The river width is 1 kilometer. Shortest time to reach the shore is 1/4 of an hour. What is the velocity of the river? Now, this is sort of an easy question, but it's very basic. It's extremely basic. So let's first draw the river. Let this be the river. This is the width 1 kilometer, which is, let's say, it's D. And it says that, okay, now it has to cross in the shortest time possible, right? So, and shortest time possible will only come, okay, let's say the velocity, the final velocity of boat VB final is along this way, right? Then it will be the shortest time. Okay, this is a bit of a guesswork, but intellectually this will be the shortest, right? Now we know that the river is flowing in this direction. VR is in this direction, right? And so that means the boat will have to set off sail in sort of like this direction to have a resultant velocity in this direction. So basically, let's take, it goes in this direction, right? So this is V boat relative. Okay, and this will be the V of R, and this forms a perfect a vector sum, which basically is VPF equals to VB, VBF equals to VBR plus velocity of river. Okay, now this is a 90-degree. Therefore, this means that VBF equals to root of VBR square minus VR square, right? Because of Pythagoras theorem. And okay, so the time taken to reach the next shore is d by VB final, right? Final velocity. D is 1 km. This is root of VBR square, which is 5. So the boat will obviously go in the same speed, right? Its speed will not change, okay, because the velocity of river is in the x direction, but velocity of boat is in only y direction. Hana? So this will not change. So v of boat relative to the river will remain 5, which is 25 minus and VR square, right? VR square is basically we have to find out, right? So you put in time, you put in this, and you get VR as basically 3 kilometers per hour. This is the answer. Now let's move on to the next part of the question. So next part is saying basically we've been given the velocity of stream, we've been given velocity of a man in still water swimming, and it says, the question says, to reach the shore in the shortest time, what is theta? Okay, now we have to prove that theta is basically 0, right? In the last question we basically assumed that. Now we have to prove. Okay, so this is the stream, this is theta, right? So it has to go in this direction, right? Because we know that velocity of what is it called, the stream, is in this direction. The velocity of man will be in this direction to make resultant velocity in this direction, which is v man resultant, let's say. Okay, now we know that v man, okay, so basically therefore same trick, we say time equals d by v man relative, right? Basically the final velocity after all the calculation and shit like that, right? So, and v man relative is basically v man cos theta, right? V man cos theta, right? So we know that the time taken should be minimum, and if this is minimum, right, and theta is our only variable, cos theta should be maximum, right? Cos theta is maximum when it is 1, and theta that time will be 0 degree. Therefore, proved. Okay. Yeah, now that question is done. Now, let's move on to our last question. Sorry for this. Okay. So it says, the question name is Observer Special. Airplanes A and B are flying at 30 degree and 60 degree. Velocity of A is 100 root 3 meter per second. At time t equals 0, observer on A reports that B is at a distance 500 meters from A. And he also reports that B is moving with a velocity perpendicular to A. Note that this observer is on A itself. If at t equals t0, A just escapes being hit by B, what is t0? Okay. Now, this question. So this is a very interesting question. Okay. Let's take this horizontal. Okay. This is VA. This is plane A. And VB is going like this. Let's say its velocity is like this. VB. We know that